So today we're going to talk about a concept called symmetry, right? When we talk about symmetry, we're actually talking about if I had a shape, let's say I had like a shape that kind of looked like this, right? And then in grade 8, we would have those little mirrors that we would actually use to copy that shape on the other side of the mirror, right? So this would be an example of what would happen if we were finding the mirror along the y-axis, right? So here are the definitions of symmetry, okay? Every time we do a new lesson in this video, we're going to have the concept of symmetry up here, and then we're going to use that to go and do the problems that we have here, okay? Now, for the y-axis, if replacing the x with negative x results in the same equation. So you get the equation, you replace the x with negative x, and then you simplify it. And if it comes out to be the same, that means it is symmetrical about the y-axis. So let's go and practice that. Okay, so let's determine the symmetries for the graph y is equal to x minus 2 squared plus x plus times x plus 2 squared. So let's go and do the first type that we have here. So let's go and take a look at this one, okay? So we're going to try and check to see if the solution for the y-axis will work. So here's what we'll do. We'll replace x with negative x. Okay, so we'll start with y is equal to negative of x minus 2 in the brackets squared times negative x plus 2 squared. So let's do that. Let's pull out a negative 1 from this bracket here. So we're going to pull out minus 1 inside the bracket, and we end up with x plus 2. So we have a minus 1 and an x plus 2, but now remember, the whole thing is squared. And then we'll do the same for the other one. So we pull out a negative 1 inside our bracket, and what we're left with inside the bracket is x minus 2. But it's all squared again. So now that squared is going to be applied to this and this, the other one, and the same can be said for this one and this one. All right, so now let's simplify. So we end up with y is equal to negative 1 squared times x plus 2 squared times negative 1 squared times x minus 2 squared. Well, this is the original equation that we're looking at, right? And we're trying to make it so that our original equation, that our final answer looks like our original equation. So let's see if this simplifies properly. So negative 1 squared is just 1, so that's gone. Negative 1 squared again in the second bit here also is 1. So both of these turn into 1. So we end up with y is equal to x plus 2 squared times x minus 1 squared. Now we can just rearrange these two because 3 times 2 is the same as 2 times 3. So we can just rearrange it to be the following final answer. So based on that final answer, we should say the following. It worked, man. It worked. So since the final equation is equal to the original equation, we should be able to say that the graph is symmetric with respect to the y-axis. And we're done. So simply, the graph is symmetric. WRT means with respect to the y-axis. What we're going to do now is we're going to take a look at the symmetry with respect to the y-axis. So what I'm going to do is I'm going to take all this information and I'm going to give you a quick picture of what's happening. So imagine we have a line that looks like this. Okay? And what we're going to be doing is we're going to take a look at that. I.e., if we're looking at something that is symmetrical to the x-axis, then we literally are thinking about having a mirror underneath our picture. And then all we're going to do is make it so we're going to try and make sure that our equation for our graph looks identical to that on the other side of the x-axis. So here is our original equation. So now we're checking to see if it's symmetrical with respect to the x-axis. So now the solution is starting by replacing y with negative y. So that means we get negative y is equal to x minus 2 squared times x plus 2 squared. When we get rid of the negative y, the negative on the left side, we end up with the following. Y is equal to negative of x minus 2 all squared times x plus 2 all squared. And that's a problem because we cannot get rid of that minus sign. Therefore, so the graph is not symmetrical because we cannot physically change this equation that we have as our final solution for y to make it look like our original equation back here. So therefore, the graph is not symmetrical with respect to the x-axis. So now what I'd like to do is I'd like to check to see if this graph is symmetrical with respect to the x-axis, the origin. So imagine I have a graph that looks like this. Here's my x-axis, my origin, and what happens is I've got, say, something that does this. So what would happen is our graph would be, all our x's would change to negative x's and all our y's would change to negative y's, right? And what would happen is we'd have something that looks like this. So the graph would look almost identical, but it would be reflected through the origin. So what we're going to do is we're going to check that by replacing our x's with negative x's and our y's with negative y's. So let's see what happens when we do that to our equation. So we end up with this. Negative y is equal to negative x minus 2 and negative x plus 2 all squared. From before, we did this one already, and we found that our solution was the original equation. So we got x minus 2 squared when we simplified an x plus 2 all squared, but we still have the minus y. So when we divide by the minus, you end up with y is equal to negative of x minus 2 squared times x plus 2 squared. So there's no way to make these things the same. So that means this does not become that. So here's what we say. The graph is not symmetrical with respect to the origin. And now I've just shrinked it so that you get all the information on the screen. Okay? So now your homework is going to be on page 32. And you're going to do questions number 31, 43, 49, 57, 63, 65, 67, 69, and 72 are optional. But I'd suggest you try them. Okay? And then after this is our review.